Open your book to page 500. Today's lesson is learn how to find the sum of infinite geometric series. So if you look on page 500, let's say if you have the series 1/2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus dot dot dot. So this goes on forever, right? Now, when you have S1, S1 means sum of the first term, so it would be just 1/2. Okay? Now you go to S2, means you're adding the first two terms. So you add this two, will give you 3 over 4. Then S3 means you're adding the first three terms. So this will give you 7 over 8. Then S4, adding the first four terms, this will give you 15 over 16. And if you keep going, when you add the S10, now you have to write out the 10 terms and you add, right? So S10, this will give you 1023, 1024. Now if you notice, the number, it gets closer and closer to 1. Okay? So to the formula for the sum, the infinite sum, is on page 501. Notice there's no subscript. Okay? The S1 means sum of one term. Okay? S2 means sum of two terms. S3 means sum of three terms. But when you don't have a subscript, means you adding the infinite number of terms. So this is the infinite sum when it's on subscript. Okay? And this would be equal to T1 over 1 minus R. Okay? And this came from the regular formula when you have S of n equal to T1 times 1 minus R to the n over 1 minus R. So when you have infinite series and when the numbers get smaller and smaller, okay, when number gets smaller and smaller and smaller, when n approaches infinity, okay, this approach to 0. And so again, when n approach to infinity, r to the infinity, when r is less than, absolute value is less than 1, it gets smaller and smaller, and then it approaches to 0, and therefore this becomes that equation. So that's where it came from. Okay. Now if you look at the theorem, notice on the theorem on page 501, in order to use this equation, okay, the absolute value of r had to be less than 1. Okay? So in order to use these for the infinite sum, then the absolute value of r had to be less than 1. Now what this means is that when you just look at the number, not the sign, just look at the number itself, the number will get smaller and smaller and smaller. Okay? So that's what it means. So if you look at example 1, if you look at the A, you have 8 minus 4 plus 2 minus 1 plus dot dot dot. And the B, you got 8 plus 12 plus 18 plus 27 plus dot 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 dot. Okay? So notice the number gets bigger. You got 8, 12, 18, 27. Okay? So in this case, there would be no sum. Because number gets bigger and bigger, the sum is going to get bigger and bigger. Okay? Now over here, notice number gets smaller. Again, don't worry about the sign. Just look at the number. Right? That's what absolute value means. Okay? So notice it's 8, 4, 2, 1. Right? The number gets smaller and smaller. So this one will have sum. And to find sum is very simple. Right? The r is equal to negative 1/2. Right? And to figure out r, you just put any term over the previous term. Right? So negative 4 over 8 give you negative 1/2. Right? Or use this one here. Right? Negative 1 over 2 give you negative 1/2, right? So again, this is infinite sum and the number gets smaller, so this will have sum. So S equal to T1 over 1 minus R. So S equal to 8 over 1 minus R is negative 1/2. Okay, and so S equal to, use your calculator, you work it out. Okay, now when you have complex fraction, you multiply 18 by 2, right? So you multiply 18 by 2 to simplify. Okay? So you're going to get 16 over, this becomes 2 plus 1 give you 3, right? Okay, and that's it. Okay. Now let's go to example 2. Example 2, you can also use infinite series to convert repeating decimal into fraction. So like on page 501, example 2, So you got 0.121212 dot 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 dot, right? So you learned how to do this before, right? So we're gonna do it two methods, okay? So we do the old method. You're gonna have n equal to 0.121212 dot dot dot, right? Now there are 2 digits repeating, so you have to times by 100. So this is kind of the review from before. So it'd be 12.1212 dot 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 dot. So when you subtract, you're going to get 99n equal to 12 and divide by 99. So you're going to get n equal to, and reduce by 3. So you're going to get that, okay? Now if you use infinite series, you're going to make this in infinite series first. So s equal to 0.12 plus 0.0012 plus 0.000012 plus dot dot dot, right? So again, so this is this first term, this is your second term, this is your third term, okay? And then from here, r equal to 0.01, right? There, you can tell by there are 2 additional zeros, right? So that's 0.01. Okay, so s equal to t1 over 1 minus r. So s equal to 0.12 over 1 minus 0.01. So s equal to 0.12 over 0.99. So s equal to 12 over 99. So s equal to same thing, right? Same. Okay, so you get the same answer. So you can use that. Use that to convert. Okay. Okay, so let's just do one more example quick. Okay, let's go to page 502. Let's say if you have 12. Okay, look at number 12. Okay, so it tells you that this is the infinite geometric series, right? And you can tell it by this, right? And from 1 to infinity, right? So let's go and, so s equal to 3 to the 1, 4 to the 1 minus 1. And let's go and do at least 2 terms so we can figure out what the r is, right? So 3 to the 2 over 4 to the 2 minus 1 plus dot dot dot, right? So you're going to get 3 over, okay, now this is 4 to the 0 power, so 4 to the 0 power is 1. Okay, this one is 3 squared, give you 9 over 4. Okay. So in this case, your r is going to be 3 over 4, right? Because you can tell, right? 3 times 3 give you 9, and 1 times 4 give you 4, right? So r equal to 3 over 4. Okay, so the number is getting smaller, so you have sum, right? So s equal to t1 over 1 minus r. So s equal to 3 over 1 minus 3 over 4. And in this case, you can do it either way. You can go and simplify this, or and then you divide, or you can just go and multiply by 4. Right? Simplify complex fraction, right? So you get 12 over 4 minus 3. So s equal to 12. Okay, so let's go ahead and let's go and do some practice.